And what we are going to be doing in this lesson is we're going to use what we've learned about trigonometry, right? What we know about trig, what we know about writing equations and the transformations and the unit circle, and now using our calculator to model situations in the real world that vary sinusoidally, right? So we're going to derive an equation. We're going to come up with an equation based off of the information that's given to us and ultimately make predictions, right? So this is going to be calculator based. So while Desmos is a great tool, I'm going to use a graphing calculator a lot more, and I would like for you to do that so that you're getting practice with the calculator functions, right? So use your graphing calculator if you downloaded the app, if you downloaded, the application that I had sent out. If you need access to that, if you don't remember, if you never downloaded it and you want it, let me know, okay? So that is what we're going to be doing today. So can you think of anything that would be modeled mathematically by a periodic function, right? A function that, periodic function. Think. Pause the video and think. See if you can make a list. Just think about what you've seen or what you know. Like, think about things in the world. Maybe you thought of phases of the moon. Maybe you thought of the depth of water, high tide and low tide, right? That has to do with the time of day, right? And it varies sinusoidally. Maybe the length of the day, right? Think about what happens throughout the year, right? That also has to do with the phases of the moon, right? Like, think about what happens. Oh, the days get shorter, and then you get to the shortest day of the year, and the days get longer. That's a periodic function. It's going to vary sinusoidally. Voltage coming out of a wall socket. Light waves. Sound waves. Temperature. Right? There's a lot of different things that vary sinusoidally. This is not a exhaustive list, obviously, so maybe you can come up with some more and keep thinking about them. Maybe you'll be able to use one in the future, maybe next week. And we're going to start with this problem right here. So I want to kind of introduce it with this problem. So low tide at a port is 3.5 feet and occurs at midnight. After 6 hours, the port is at high tide, which is 16.5 feet. Our first goal is to write a sinusoidal model that gives the tide depth, d in feet, so it's telling us about the units, and t in hours. Let t equal 0 represent midnight, okay? So low tide is at midnight. I'm sorry, I didn't want to write that. Is 3.5 feet. That's your minimum. And that's going to be at 0. And I'm saying 0 because t equals 0 is midnight, right? So I do think 0 equals midnight. And t is the hours after midnight or since midnight, right? I think that's an important thing for us to make a note of. And then high tide is, 16.5 feet. That's your maximum, and that happens at 6, right? So this is at t equals 0. This is going to be at t equals 6 because that's 6 a.m., right? 6 hours after midnight. So what we know is that this, when we graph it, is going to look something like this. Oh, that was beautiful, right? So I know that my lowest is going to be at 3.5, and my highest is going to be at 16.5. This will be 0. This will be 6. What will this be then? 12. Right? Right? So we now know the period. The period of this, it takes 12 hours for it to get from low tide back to low tide, right? Or high tide back to high tide. So the period is going to be 12. So B for the equation is going to be 360 divided by 12, which is 30. okay? Let's think. So 3.5 to 16.5. What is the gap between that? What am I adding? I'm adding 13? Yeah, I'm adding 13. So my A value, my amplitude, is going to be 13 divided by 2, or 6.5. Right, so I have the amplitude, I have B. The phase shift, there isn't one, right? It starts at 0. But the sinusoidal axis, the D, the sinusoidal axis, is, well, what's halfway between 13.5 and 16.5? Well, I'm going to be adding 6.5 to this, right? So isn't that going to be at 10? At y equals 10. So I have enough to write this equation for A. So y equals, and I'm just doing it based off of this one rotation that they're telling me. And starting at the lowest point, so it's going to be negative 6.5. It starts at the lowest, so it's cosine. B is 30, theta, plus 10. Right, so this is the equation. And then I can pick, theta is going to be, or I guess really this is T, right? This is T and this is D is what I really should have done. Right, I could pick T is going to represent the hours after midnight. Right, so I could pick any, I could say, well, what happens 48 hours after midnight? That wasn't a great example. What happened 36 hours after midnight? What is the depth of the water? And you would be able to plug into this equation and get it. What happens 3 hours before midnight? Right? So you're not putting in the time, you're putting in the number of hours since midnight. So find out the number of low tides and high tides in a 24-hour period. So let's see. Low tide. I'm going to write LT. Low tide. It happens at midnight. It happens 12 hours after midnight. So that's 0, which is noon, which would be 12. And then it's going to happen 12 hours later again, which would be midnight again, isn't it? And that would be 24. Let's see about high tide. So it hits high tide at 6 a.m., which would be 6. And then 12 hours later, which would be 6 p.m., which would be 18. And then 12 hours later, but that's already after 24 hours, right? So it has 3 low tides and 2 high tides in a 24-hour period. Explain, this is my favorite part. Explain how the graph of the function you wrote in part A, so this one, is related to the graph that shows the tide depth after 3 a.m. So let's say we didn't want to start this at 0. We wanted to start this at 3 a.m. So now your start is 3 a.m. Well, let's think about starts. Oh, isn't that talking about a phase shift? Yes, it is. Right, so this is talking about a phase shift. So let's say we wanted to start it at 3 a.m. What's the depth of the water at 3 a.m.? Why don't we use our equation? You might know it, but why don't we use our equation? 30 times, that's going to be 3, plus 10. Don't pick up your calculators. Do not pick up your calculators. This is going to be amazing, guys. Cosine of 90. Check that out. Special angle. So this must be one of the quarters, right? This has to be, this is going to be halfway right here. Oh, isn't that just a sine function? Oh my God. Wow, right? So, I mean, hey, let's just finish this. The cosine of 90, isn't that 0? Oh, isn't that just 10? So the depth at 3 a.m. is 10 feet. Neat, right? So this is just a sine function. This is the same function with the phase shift. So I'm now going to start it here, and it's going up first, so it's going to be positive 6.5. Sine of still 30. Now it's going to be theta. Nope, t. It's going to be t. I'm messing it up again. I'm so used to using x and y. t minus 3, right? So then when I plug in 3, I get 3 minus 3 is 0. Sine of 0 is 0, right? So that's telling me that I'm now starting it at 3 a.m. and then still plus 10, right? So this is just a phase shift. It's the same. And if you want to go ahead and put this in your calculator and check it out, go for it. Neat. Okay, so this is our first example. This next one that we're going to be looking at, you guys actually have, if you printed out the capture sheet, and I have an answer key to this capture sheet, if you'd like to work this one out with me, if you've printed it and you want to try it on your own before you join me with it, I encourage that. I think that's a fabulous idea. If not, just join me in it. So suppose that the water wheel shown below rotates at 6 revolutions per minute. So it does 6 revolutions in 60 seconds, in 1 minute. You start your stopwatch, and 2 seconds later, point P on the rim of the wheel is at its greatest height. Okay? So in 2 seconds, it gets to its maximum. Right? But it does 6 revolutions in 60 seconds. So how long does it take to do 1 revolution? So let's see. 1 revolution is going to be 10 seconds. So think about this. If it gets to its max at 2 seconds, when's its next max going to happen? 2 plus 10. At 12 seconds, it's also going to have a maximum. Right? So you're to model the distance, d, in feet of point P from the surface of the water in terms of the number of seconds t the stopwatch reads. Assuming that d varies sinusoidally with t, sketch the graph that models this situation. So you've got 7 and 6. Ooh, ooh. So that means this little part right here has to be 1, right? The radius of that circle is 7. The radius of the wheel is 7. So I'm going to go ahead and I'm going to start it. This is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this axis will be the number of seconds and this will be the distance, or I guess the height is a better way to say it, distance of P, and this is going to be in feet. So we don't know where it starts, but we know it gets to its maximum at 2 seconds. Well, what is its maximum? The maximum amount of above the water, right? Well, 6 plus 7 is going to be the maximum. So the maximum is going to be 6 plus 7, because that 1 is underneath water, which is going to be 13 feet. The minimum, it's only ever going to get 1 foot below water, so the minimum is going to be, I guess, -1 feet. So I'll say this is -1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh no, it's okay. So at 2 seconds, it gets to its maximum. And then at 12 seconds, it's also at its maximum. So halfway between that, it's going to get to its minimum, right? Isn't that how this works? If it's very sinusoidally, it's going to go all the way down halfway between, right? So that's a full rotation. Halfway between those, it's going to get to its minimum at -1. So what is halfway between 2 and 12? 7. 2, 3, 4, 5, 6, 7. So at 7, it's going to be its minimum. Well, when is it going to get to like that middle? Think about these points. When is it over here and over here? Okay. So what's halfway between 2 and 7? Because this is now me like splitting it up into quarters. 4.5. 2, 3, 4.5. So I'm going to put a line there. I'm going to label it. So even though I did all these tick marks, this is the key part that I'm going to label. 7 and 12, I'm adding 2.5, right? So 9.5. So those are my quarters. Well, what is halfway between -1 and 13? 6. 1, 2, 3, 4, 5, 6. What's this called? Oh, it's the sinusoidal axis. I'm going to label it like that, but I guess I could just do this. So at 4.5, it's going to be at 6. At 9.5 seconds, it's going to be at 6 also. And then there's, oof. Oh, this is no judgment. Right? And it does keep going, obviously, right? It turns around. We know that. Not a beautiful drawing, but it does turn around. I should label these. 2, 13, 4.56, 7, -1, 9.5. What is that? 6. And then my last point that I have here is 12, 13. Okay, so just like we did in the warm-up, we're going to use this graph to, shocking, come up with an equation. Right? So I've got everything labeled. I don't think I missed anything. I sketched the graph that models this situation. Okay. So I took a picture of it so that I can reference it when we get to the next page. So if you've got it on your paper, great. If you need to take a picture of it as well, do that. Oh, just kidding. It's not on the next page. I still have the graph. I was more prepared than I thought. It's okay. So where's the sinusoidal axis? I'm using another color so you can see my answers to these. Y = 6. What is the amplitude from the mid? So like, what is this distance? Right? So your amplitude from 6 to 13 is 7. Whoa! Isn't that just the radius? Neat. Right? This Y = 6 is just the distance from the water to the center of the circle. This is the radius of that circle. What are the maximum minimums? What are the bounds of it, right? So it's going to go from -1 is the minimum to 13 is the maximum. Where should you start your graph, right? I'm going to start it at the first piece of information I knew. So 2 seconds, we knew that it reached 13 feet. Right? I'm not going to start it at 0. After I read an equation, I'll be able to figure that out. But I don't know that yet. What's the period? Well, the period is going to be, we talked about that right away. Right? So from 2 to 12 is 10 seconds, right? It takes 10 seconds to make 1 revolution. If it takes 60 seconds to make 6, it's 10 seconds to make 1. So 10 seconds. Where should your graph end? Well, 2 plus 10, so at 12 seconds. Should this, based off of what I have drawn, be sine or cosine? I'm going to make it a cosine, and obviously your answers can vary for that, but I would say based off of the information you're giving it, we want it to be cosine. Why? Why? The reason that we want it to be cosine is it starts at the max. You're starting from a maximum. So maybe now I'll take a picture of this information. Okay, so this lets us now wants us to tell the A, B, C, and D, right? After we just wrote all that information. Your A value, my phone just locked. Give me a moment, guys. And it's very slow. It's okay. My A value is going to be, well, I need my amplitude, right? And since I'm starting at the maximum, it's going to be positive. So it's going to be 7. My B value, well, the period was 10. So 360 divided by 10, 36. Right, degree mode. C C is going to be the phase shift. That matters. It's where I'm starting, right? So C is going to be 2. D is going to be the sinusoidal axis, so your D is going to be 6. This equation is going to be y equals 7 cosine of 36 theta minus 2 plus 6. I'm the worst with these letters. D equals 7 cosine of 36 t minus 2 plus 6, right? Because t represents the seconds on the stopwatch. And d is the feet above water. So make sure you've got this equation down. So we're going to do some more work with it. We're going to answer some fun questions about this particular water wheel. So again, I'm going to take a picture of it, either have it written down or take a picture of it. So we're going to use our model. I'm going to write it at the top, actually. Ah! 7 cosine 36 t minus 2 plus 6. Use your model to predict values for t and for d. How far is point P from the water at t equals 5.5? So at 5.5 seconds, how far from the water is point P? So we're going to plug in, right? And we're going to show our setup just like we do. 7 cosine of 5.5, 36. 5.5 minus 2 plus 6. So let's see, d equals 7 cosine of what is 5.5 minus 2 is 3.5 times 36 is 126 plus 6. I'm going to use a calculator. Degree mode. Where's my algebraically part here? It's supposed to be graphically and algebraically. So when I put this in my calculator, I'm checking I'm in degree mode, and I'm going to show you the graph in general to look at this in a moment. But when I pull up the calculator, sadly, my annotations go away. So I'm going to set it up first. So I get 7 cosine of 126 plus 6. I get 1.88, I'll say 6, and it's feet above water. If you say 1.885, that's fine too. Okay, so we're going to come back to looking at this graphically in a few minutes. So don't forget this, but this is what I got as my answer. I tend to like to simplify this piece of it first to get this, because if it's a special angle, I don't need a calculator. And then if it's not a special angle, I've simplified it, so I'm going to avoid some of those calculator issues with parentheses. So if you're getting something different than me, maybe it's because you didn't simplify, or you're forgetting parentheses or putting them in the wrong place idea. So when is the first time after 2 seconds that point P is at 10 feet above the water? So I'm going to hold on the graphically part, and we're going to do it algebraically, and then we'll look graphically when I pull up the calculator in a moment. So algebraically, 10 feet. So there's going to be more than one time. So you think about what the graph looks like. I have a graph that looks like this, right? So I know that if I were to draw a line at 10 feet, is 10 feet the midline? What was this? 13. Oh no, 6 was. Oh, 10 feet was the midline of the other one. Sorry. Whew. This one goes below, doesn't it? This is terrible. This goes to -1, and then the midline was at 6. That was 6. But at 10, that's going to be somewhere here. We have it hit at 2 points, and then it obviously keeps going. So I want to know this, right? I want to actually know when it's saying what time, I want to know what x is. What is x? Right? And I'll show you how to do this graphically in a moment, but algebraically, we're going to say, well, 10 equals to, let's see, 7 cosine 36 t minus 2 plus 6. And we're going to go ahead and we're going to do some solving. So I'm going to subtract 6, make it 4 equals 7 cosine of 36 t minus 2. Divide by 7, 4/7 equals cosine of 36. I'm going to distribute that. T minus, what is that? 72? Yes. Yes, it is. Right? Distribute that 36. Okay. So here's where we're going to pull in actually what we did in our last objective. Right? I need to somehow get inside of this. Right? I need to get rid of this cosine. So how do you get rid of a cosine? What's the inverse operation? Oh my goodness, cosine inverse, right? If I take the cosine inverse of both sides, that's going to make this go away. And then I'm going to be left with the cosine inverse of 4/7, I should be in degree mode, equals to 36t minus 72. I'll add, and I'm going to go into a calculator at the very end, so I don't round anything, plus 72, and then I'm going to end up dividing that by 36, and that will give me t. So I'm going to, again, take a picture of this, and I'm going to show you what you're going to do graphically and how you put this into your calculator. So either write it down or take a picture of it so that you can join me in some of these fun calculator functions. Took my picture. Got my calculator. And I'm going to go ahead, and my first thing that I'm going to do is I'm going to plug in the equation right here. So we've got 7 cosine of, what is this? 36. I couldn't read my handwriting for a second, sorry. 36 x minus 2, close parentheses, plus 6. Am I in the right mode? Yes. And I'm going to go ahead and graph it. Whoa. Let me change that window a little bit. Right? So maybe I don't need my x minimum to be quite that extreme. I'll make it go from 0 to like 30. I'll make this go from -10 to 15. Beautiful. Okay. So now what I want to do, and let me remember what I had to do. I wanted to show you that first one. This first one with how far did the point go in 5.5 seconds. So if I do second trace value and type 5.5, I get 1.885 or 1.886, which was the same thing I got algebraically, right? So my calculator can support my answer for this, right? My second one, I don't know why it doesn't say algebraically, I guess I cut it off, is I want to figure that other one out graphically. We got it algebraically. I didn't actually finish writing the answer, but we got it, and then I'll show you what you can do, how you get it in your calculator. So the first thing is let's finish it in our calculator. So I had it as cosine inverse of 4/7 plus 72. And then I'm going to push enter. And then divide it by 36. I got 3.53. What's the units? 3.532 seconds. 3.532. I'm going to write that down so I can see if algebraically we get the same thing. 3.5, and that makes sense, right? 10, does it make sense? Hopefully it does. Let's find out. Oh, that's not after. What is the first? Okay, let's see. So graph. It does make sense because that's before it gets to the midline, and we're looking for 10, which is above the midline. So I'm going to go ahead and y equals, I'm going to put the line that it wants me to have it intersect, right, that 10. And I try to draw this in a picture. And when I graph it, I want this right here. I want that value right there, right? This is going to be the first time. So if you think about the graph that I'm focused on is just from here to here. I can even restrict that, can I? No, it's fine. It's fine. Second trace, intersect. You've used this before. And I'm going to go all the way over to that point that I'm talking about. Right there. I'm going to get close to it. I'm going to push enter, enter, enter. 3.532. Isn't that crazy? Right? So crazy. Right? I got the same answer that I got algebraically. This is just doing it graphically, and I drew a picture. I drew the graph, and I sketched a picture. I drew the graph, and I drew the line, and I talked about which point am I looking for the intersection of. So, calculator stuff. Practice using your calculator. You guys have lots of practice that the textbook has with this. Some of it is harder than others. I focused on assigning odds just so that you could check your work in the back of the book, but I encourage you to actually work out the problems and work out a few of them and see how you do with it. But that's it. That's all I've got for you guys, right? So what we did in the last lesson is use what we've learned about trig, like everything we've learned about it, and did lots of application with it, right? So we modeled situations in the real world, and there's a lot of different situations that are modeled sinusoidally and that vary sinusoidally to come up with that equation and make predictions. So thanks for watching. Thanks for watching all of my lessons, I hope. And if you've got questions, feel free to reach out. And otherwise, take care.